Guys, I'm Jethro Arile from the Rizal National Science High School, and I'm tasked to talk about the conditions of involving hyperbola. Now, hyperbola is a tricky thing because it looks like two parabolas, but it's not actually two parabolas. So let's go to our solving table and let's go. Our first condition, which is the length, which the given are the two lengths, the transverse axis and the converse axis. Here we have the center of the graph is 0, 0, the origin. And the length of the transverse axis here is 10 units. The length of the converse axis is 8 units. So what we do here is we need to find a squared and b squared so that we have the formula. So let us remember that the transverse axis is equal to 2a and the converse axis is equal to 2b, which is one of the definitions of it. So here we have 10 is equal to 2a. We must remember that we just need to substitute these two values to these formulas. So we have 10 is equal to 2a, so 5 is equal to a. Then we have the converse axis, which is equal to 2b. So 8 is equal to 2b and 4 is equal to b. So let's just substitute these values here. So x squared over the square root of a, which is 25, so 25 minus y squared over the square root of b, which is 16, so is equal to 1. So there we have it. We have the first condition. Our next condition, which we have the two foci and the transverse axis. So we have -2, -3 and 6, -3, and our center is equal to is 2, -3. And how did we find our center? We used the never changing y, which is never -3 and -3, because logically if the y of the center is somewhere else, then we have a problem. So we found the midpoint of the x values of the first foci and the second foci. We have 2c is equal to the absolute value of x1 minus x2. So 2c is equal to 6 minus -2. 2c is equal to 8, and divide both sides by 2, so c is equal to 4. So now we need to find the standard formula of our hyperbola. So we have x squared minus y squared minus a squared minus b squared. How will we find the values of a squared and b squared? Of course, we will use this. And note, this is not a Pythagorean theorem if the hyperbola is involved. Well, use the Pythagorean theorem for other things, but if the hyperbola is involved, it's not the Pythagorean theorem. Trust me, you will get this wrong if you just so on. So we have c is equal to 4 and b is equal to 3 because of the never changing y, and so we substitute this. So a squared is what we are finding here. So c is equal to 4 and b is equal to 3. C squared is equal to 16, a squared because we're finding it, and plus b squared, which is equal to 3. So we transpose 9, so we have 16 minus 9 and is equal to 7, is equal to a squared. So we don't need to find a because a is equal to square root of 7, but we don't necessarily need this because we're finding this. So we have x squared minus, over 7 minus y squared over 9 is equal to 1. Guys, I hope you liked the video, and if you want more tutorial videos, please ask my mentor, it's Robert Iscadido, about more lessons about conic sections and other calculus topics. So thank you all guys for watching this video, and goodbye.